Welcome to another spherical moment. In this video, we discuss a Russian mathematics Olympiad problem on tiling n by n board with 2 by 1 tiles. For any tiling of an n by n board using 2 by 1 tiles, there exists a straight line which divides the board into two, not necessarily equal parts, and cuts no tile. Prove or disprove the statement for 1, n equals to 6, 2, n equals to 8. Let us understand the question a bit more. Consider a 6 by 6 board. Using 2 by 1 tiles, we can obtain a tiling for the board as follows. Furthermore, for this tiling, there exists a straight line which divides the board into two parts and cuts no tile. The statement says this holds for any tiling, that is, no matter how we arrange the 2 by 1 tiles, as long as they fit the board with no overlap of tiles. Prove or disprove the statement for part 1, n equals to 6, part 2, n equals to 8. Can you figure it out? Part 1 is true. Note that each 2 by 1 tile can be cut by a horizontal or vertical line at most once. Also, any line divides the board into two parts with even area. This implies that each line must cut at least two tiles. For if some line cuts exactly one tile, then the two parts are of odd area. Suppose for some tiling that any straight line which divides the board into two parts must cut some tiles. There are 5 horizontal lines and 5 vertical lines, which make a total of 10 lines. Then 10 lines cut a total of at least 20 tiles. Since there are 18 tiles on the board, there exists some tile that is cut at least 2 times by pigeonhole principle, a contradiction to start. This completes the proof. Let us try to apply the same argument to prove part 2. Note that each 2 by 1 tile can be cut by a horizontal or vertical line at most once. Any line divides the board into two parts with even area, implies each line must cut at least 2 tiles. Suppose for some tiling that any straight line which divides the board into two parts must cut some tiles. There are 7 horizontal and 7 vertical lines, which make a total of 14 lines. Then 14 lines cut a total of at least 28 tiles. Since there are 32 tiles on the board, there exists some tile that is cut at least once by pigeonhole principle. However, there is no contradiction to start. Hence, this argument does not hold for an 8 by 8 board. Actually, the statement is false for an 8 by 8 board. That is, there exists some tiling such that any straight line which divides the board into two parts must cut some tiles. The following is such a tiling. Let us verify that every straight line cuts some tile. This completes the proof. I shall leave you with a variant. Prove or disprove for any tiling of the following staircase board using 2x1 tiles. There exists a straight line which divides the board into two not necessary equal parts and cuts no tile. I hope you enjoyed the video. Please share, like and subscribe for the latest video. Leave in comments any problems or topics you are interested in. Alternatively, you may email me. Thank you for watching.